difference of two proportions. I think that we have looked at this example in the previous unit when we were talking about sampling distributions, but now we're going to use we have some more information about how to use that sampling distribution to construct a confidence interval. So, scientists predict that global warming may have big effects on the polar regions within the next 100 years. One of the possible effects is that the northern ice cap may completely melt. Would this bother you a great deal, some, a little, or not at all if it actually happened? The GSS asked the same question, and this was the results. This is the results from a 2010 GSS survey, and this is the results from an introductory statistics course at Duke University. So our parameter is the difference between the proportions of all Duke students and all Americans who say they would be bothered a great deal by the northern ice cap completely melting. And our point estimate is the difference between the proportions of sampled Duke students and sampled Americans who would be bothered a great deal by the northern ice cap completely melting. So we go back here, right? A great deal. 454 out of 680 is 0.67. And Duke student 69 out of 105 is 0.66. Details are the same as before. Our confidence interval is still a point estimate plus or minus a margin of error. It's still going to be in this case, your point estimate is going to be P1 minus P2 hat. And you're still going to use the z-score. It's just that we need the standard error for the point estimate of the P Duke minus PUS. So, standard error of the difference between the two sample proportions. Remember this formula? Very ugly looking. But P1, 1 minus P1 over N1 plus P2, 1 minus P2 over N2. And we take the square root of that. Conditions, independence within groups. So we need our groups to be sampled randomly. We're assuming the Duke group represents a random sample as well, although if it's taken just an introductory statistics course, that may not be a random sample of Duke students. Sounds like a convenient sample to me. But we'll assume that the Duke group represents a random sample. We need to check our 10% condition, right? Independence is the 10% condition. So our N for Duke was 105. That's less than 10% of all Duke students. 680 is less than 10% of all Americans. And we need to assume that the attitudes of Duke students are independent of each other and attitudes of U.S. residents are independent of each other. And also independence between groups. The sample Duke students and the U.S. residents are independent of each other. If we randomly sampled Duke students and then we asked their parents to be our U.S. resident sample, that would not be independence between groups. Our large counts condition, at least 10 observed successes and 10 observed failures in the two groups. That's our NP. NP is at least 10, and I've totally botched writing that. Let me try that again. NP is at least 10, and N1 minus P is at least 10. All right, So, confidence interval for the difference of two proportions. Name the confidence interval and you should also state the confidence level. We'll do a 95% confidence interval. This is a two proportion Z interval for P Duke minus P US. Verify the conditions. Random, 10%, NP and N1 minus P for both samples. We're going to use our point estimate plus or minus our margin of error. Point estimate is P1 minus P2. Find the Z-score for a 95% confidence interval. That's a 1.96. Otherwise, find Z-score. Don't do that. We're not going to use the t-table. Find the Z-score using the inverse norm. And our standard error calculation is that one. Plug all the numbers in, find the confidence interval, and state the conclusion. We are 95% confident that the true difference in the proportion of Duke and US students who would say that they would be bothered a great deal by the polar ice caps completely melting is between blank and blank. All right, so here's our proportions, our p hats. For Duke, it was 0.657. For PUS, it's 0.668. We already talked about the conditions. We are assuming independence, assuming a random sample. The US is probably a random sample. The Duke is not a random sample, but we're going to assume that it is. We checked our 10% condition. So conditions, right, random, 10%, and NP and N1 minus P are both at least 10. Check those. So now this is our point estimate plus or minus our Z-score times our standard error. So 0.657 minus 0.668 plus or minus, for a 95% confidence level, our Z is 1.96, and 0.657 times 0.343 over 105 plus 0.668 times 0.332 over 680, and we plug all that into the calculator. And that gives us our point estimate is minus 0.011, and our margin of error ends up being 0.097. So our confidence interval we get from negative 0.108 to positive 0.086. And so our conclusion would be we are 95% confident that the interval from negative 0.108 to positive 0.086 captures the true difference. Captures the true difference in the proportion of Duke students and all Americans who say they would be bothered a great deal by the polar ice caps completely melting. Not going to write the rest of that, but you get the idea. Is there evidence that a greater percentage of Duke students than Americans would be bothered a great deal by melting northern ice cap? Right, remember our interval was negative 0.108 to positive 0.086. So can we say that there's a difference? No, because 0 is in the interval. It is possible that it is reasonable that the difference could be 0. So no, we cannot say that there is a difference at the 95% confidence level. All right. When constructing a confidence interval for a population proportion, we check if the observed number of successes and failures are at least 10. We're not doing a hypothesis test yet, so don't worry about that. So conditions, independence, random sample and the 10% condition met, and at least 10 successes and failures in each group. And our standard error, P1, 1 minus P1 over N1 plus P2, 1 minus P2 over N2, and take the square root of the whole thing. For a confidence interval, we're going to use P1 hat and P2 hat when we're checking these conditions and calculating the standard error, because we don't have P1 and P2. That's part of what we're trying to estimate. We only have P1 hat and P2 hat. And that's it. Ta-da!